Your free response question of day number 5. During a chemical reaction, the function y equals f of t models the amount of substance present in grams at t seconds. At the start of the reaction, t equals 0, there are 10 grams. So that's the initial amount. And that gives us a condition that we could then find what the constant is. All right, the function y equals this differential equation. dy by dt equals negative 0.02y squared. It says use the line tangent to the graph at t equals 0 to approximate the amount of substance remaining at time t equals 2. So if I say the line tangent, so first of all, I need to know what, in this case we don't have x, we have t. So we're going to go t equals, y equals, and the slope. So t is at 0. We were told the y value there is 10 grams. And then we have an equation for the slope. That's right here. So it's negative 0.02, and it's 10 squared. That's the y value to plug in. So that's 100. Move the decimal 2 to the right, and you get negative 2. So what's the equation of the tangent line? It'd be y equals negative 2. We now have x, so we're going to go t minus 0, or just t, and then add 10. Then it asks to estimate it at 2 seconds. So if I plug into the equation of the tangent line, plug in 2, and you get negative 2 times 2 plus 10, and you get the answer 6. So the question is approximate the amount. So approximately 6 grams of substance remains after 2 seconds. Done. All right, part B, and as always, you can press pause. Using the given diffie-cube, determine whether the graph of f could resemble the following graph, and then give a reason for your answer. So when I look at the derivative of the function, which is negative 0.02 y squared, could this graph resemble this diffie-cube? So to understand that, what is this telling me? Well, this is telling me that no matter what, and I want you to think of this carefully doing some number sense, that if you plug in any y value and square it, the answer is positive. And if you take a positive answer and multiply it by a negative answer, that means the derivative will always be negative. Could be at 0 would equal 0. So that means the derivative would always be negative. What does that mean? That means that y is decreasing all the time. Now look at the graph. Is this graph decreasing all the time? No. Is this, right? So could the graph could not represent f because f is only decreasing. And those are great words to use in a calculus exam. Increasing and decreasing, beautiful words. So the graph could not represent f because f is only decreasing. And you can see a part there that is not decreasing. Beautiful. All right, part C. It says find an expression for y solving that equation with that initial condition. So you're given dy by dt equals negative 0.02 y squared. Could you solve that diffie-cube? Step 1, separate the variables. So that's what I'm going to do. So I'm going to divide by y squared. I'm going to multiply by dt. Then I'm going to integrate both sides. Now this on the left is really y to the negative 2. It is not a logarithm. So when I integrate this, I'm going to add 1 to the exponent and divide by -1, so it just makes it negative. On the right side, I just have negative 0.02 and just put a t there, and then don't forget the constant. Now notice, you could multiply everything by -1 and then change the constant if you wanted to make this a positive answer. So that everything is positive now. Now, what would you do to solve for C2? Well, you have numbers to plug in. So what do you plug in for t? And what is the y value? 10. So we're going to plug in 10. We're going to plug in 0. And then you can see that 10 to the -1 is C2. Now, you don't have to write that as 1/10. So if you put it all together, what do we have? We have y to the -1 equals 0.02t plus 10 to the -1. Now, that's still not y by itself. That's y to the -1. So then how would I rewrite this so it doesn't say y to the -1? And you could just simply do the reciprocal. So think of this as 1 over y, 0.02t over 1, and then 1 over 10. So what would this be if you did the reciprocal? And if we're going to do the reciprocal, this needs to be 1 fraction on the right. So to make it 1 fraction, I'm just going to simply multiply it times 10, top and bottom. So if I do the reciprocal now, what would be in the numerator is 10, and then what would be in the denominator would be, if I multiply this times 10, you move the decimal 1 to the right. So it's 0.2t plus 1. And that's it. All right, let's look at part D. Determine the amount of substance in changing at an increasing or decreasing rate. Explain your reasoning. So, is the rate increasing? So determine whether the amount of substance is changing at an increasing or decreasing rate. So they're talking about the rate that's increasing or decreasing. So if I have dy by dt is negative 0.2y squared, then I want the rate of the rate. So that means I need to find the second derivative here and then look at it. So how would you do the second derivative? So the power rule, 2 times this in front, that's negative 0.04, or you just put a 2 in front. Subtract 1 from the exponent y, but then I need the hook, y prime, or dy by dt. Now we need to have an understanding of what's happening. I know that dy by dt is always less than or equal to 0. So this is a negative answer. This is also a negative answer. So when it says determine whether the amount of substance is changing at an increasing or decreasing level, I can tell you that a negative times a negative is positive. In fact, we could plug in what dy by dt is, which is negative 0.02y squared. So if I multiply it together, a negative times a negative is positive. And if I multiply it together, that's 0.008. And then add the exponents. So you have 0.008y cubed. That's the second derivative. So over time, is that increasing or decreasing? Now, y is greater than 0. Y is the amount of substance you have. So the amount of substance you have is going to be greater than 0, or you don't have any substance left. So because y is greater than 0, because as soon as it's 0, there's no substance left. Therefore, the rate of is increasing. As the second derivative is greater than 0, when y is greater than 0. All right. There's your free response question for today. Mr. G Math, over and out. Great job doing it.